Hello everyone again. So I hope you are doing well. I'm Mr. Zahan Zevin from SuperMap Business Development. I am warm-heartedly welcoming you all to this SMC webinar regarding envisioning spatial analysis through SuperMap GIS, which will help us to see the new era of spatial science and technology. So for those who just arrived, as I have said before, please write your name, organization, and the country that you are representing in the chat box so that we can get to know each other more throughout this whole webinar. Supermap has co-arranged this webinar with Geometric Engineering Society under the Department of Geometric Engineering, Kathmandu University, Nepal. Okay, so to start off this event, I would like to welcome Dr. Subhash Kir,
Respected.
Assistant Professor and Acting Head of Department of Geometric Engineering, Kathmandu University. So, Dr. Subhash, you there?
Okay, thank you, ma'am. Respected panelists and all national and international participants, including students from Kathmandu University from different departments and others, and including geomatics engineering alumni. Very good morning and namaste. First of all, I would like to welcome all of you in this webinar, Envisioning Spatial Analysis through SuperMap GIS, a new era of geospatial science. And I would like to express my heartfelt thanks to GES, Departmental Club of Geomatics Engineering Society, and SuperMap team for organizing this wonderful seminar. And it is also good to know that SuperMap is the third largest GIS software manufacturer in the world and the first largest in Asia. And it is also good to know that it is mainly engaged in research and development. And Department of Geomatics Engineering running programs at diploma level. That means diploma in geomatics engineering, bachelor in geomatics engineering, masters. We have two masters program, master in land administration and MEMS in geoinformatics and PhD programs. So we are also more focusing on research and development. And we can see that SuperMap team, they are also more involving on research, and we are more focusing on teaching, learning, research, and development. We can see clearly there the mutual area of interest for collaboration. As a head of the department, on behalf of the department, I'll put my commitment to work together with SuperMap GIS team in the future. And thank you for organizing such a uh, wonderful this webinar. And we look forward for the future collaboration. At SuperMap GIS 10i 2020 integrates AI GIS technology and further innovates big data GIS and 3D GIS. And department is now planning to work in this sector because geomatics engineering is itself involving new technologies. So we are more eager to have some collaboration with the Super GIS team and to work together. And at last, finally, finally, my best wishes for the successful of the program. Thank you. Thank you all.
Thank you so much, Dr. Subhash. We all are really enlightened to get to know about your valuable remarks and enthusiastic perspective on the geospatial technology aligning with SuperMap GIS. Thank you so much.
Thank you.
So now it's time for me to announce the main part of this event for which we all are waiting. Uh, the live demonstration on eclectic aspects of spatial analysis through the SuperMap GIS technology. So to present the demonstration, I would like to request Firdousi Zahara Gandes, technical engineer from SuperMap, who has been proving her excellence as a trainer and a mentor throughout most of the SMC and trainings around the world arranged internationally. So if you have any question during the presentation, please feel free to ask in the Q&A box and also in the chat box. Our technical team will try to answer the questions in the Q&A session. Gandes, can you hear me?
Yeah, I can hear you.
Yeah, the floor is all yours.
Okay, thank you, Jarin, for your greetings. So good morning, everyone. My name is Candice, and today I will be the one who present the material of this training. Okay. I will share my screen first. Okay, so everyone can see my screen?
Yes, we can see your screen.
Okay. Okay, so once again, I would like to say good morning and welcome to the SuperMap Mini Classroom webinar. And for this month SuperMap Mini Classroom webinar, we collaborate with Nepal University as with help from Jarin. And today we have the main agenda is I will show you the live demonstration of iDesktop. But before that, I would like to give you just a brief information about our SuperMap as the company profile. Okay. And this will be the outline of our presentation today. The first one is I will show you the company profile of SuperMap, and then I will explain the 5 main key technologies, the products of SuperMap, and the last one, I will show you the live demonstration of our capability to achieving the spatial analysis, both in 2D and 3D. Okay, now let's start with the SuperMap company profile. So as you may know that SuperMap is a GIS software company that was founded in 1997 by Dr. Erzun Zong. We have contributed in GIS sector for 23 years. Open opportunity for thousands employees to coping the GIS problem. And we have more than 1,000 partners coming from the 30 countries, and we have 38 branch offices and subsidiaries. And regarding our technology, you don't need to be hesitated because we already certified by trusted organization. Okay, now we move to the 5 main key technologies of SuperMap. So I hope you can fully understand our 5 main key technologies, because these 5 main key technologies is the basis one of our foundation for the whole product in SuperMap. So the first one, we have big data, and then we have the artificial intelligence and GIS integration. We have the new 3D GIS, distributed GIS, and the last one is the cross-platform GIS. And we used to call it as the BDC, Big Data, AI, Distributed, and Cross-Platform. And okay, now I will show you one by one explanation about each technology I have mentioned before. The first one is the Big Data GIS. So the first release of Big Data GIS was in 2017, and the Big Data has 2 directions. The first one is the spatial big data, and the second one is the distributed construction of classic spatial data. SuperMap Big Data support to stream, store, analyze, and visualize large data. Just like in the video in the slide, we try to meet the visualization of location data streams, such as real-time or historical location display, and then track playback and target monitoring for aircraft, vehicles, ships, and etc. Okay, the next part is about the artificial intelligence and GIS integration. So one of the AI and GIS application is on forestry industry. It helps the GIS user to detect the palm trees. From this case, we can reach the easy way to do the trees counting and other analysis to analyze your data that affect palm oil commodity. And moreover, another solution is to detect the footprint of building and clamp it to the 3D model. So we could be able to perform the analysis, the detection, visualization, as well as this picture. So as you can see in the left picture, we successfully achieving the trees counting using AI. So actually the number of trees itself is so many, it's more than 5,000. So that's why we use AI instead of manually digitize them all. And the process itself is not so complicated. So you just need to create the training data and then make the model and inference the model to your imagery. So then the software will automatically detect the palm trees of your imagery. And in the right side, we have the oblique data. So the oblique data itself is 3D data, right? But we don't do the detection immediately to the 3D model, but we do the detection to the imagery because we detect the footprints, and then the footprints, after we detect them all, we convert the footprint into such a vector file and then clamp it to the oblique data so that we can get this kind of visualization. And another AI analysis we can achieve in SuperMap is that this is one of the example is to estimate the house price affected by infrastructure. So AI can be used to estimate property price in an area. This is another level since we entering a prediction stage by involving calculating and identifying patterns from transportation, education, medical, and perhaps infrastructure's existing data. We can achieve the prediction calculation in the future. Okay, the next part is about 3D. So SuperMap was famous about its 3D technology because, as you can see on the figure displayed, the new 3D GIS technology systems are divided into four main parts, beginning with the 2D and 3D data models, 2D and 3D integration data model, which is included several types of data models such as 3D point, line, region, solid, and then 2D point, line, region, 3D network, TIM, TIN, voxel grid, and grid as well. And for the technologies itself, we provide 2D and 3D integration, including integration storage, integration analysis, and also integration software. And you may also ask, what kind of data that can be supported in our software? So don't worry, because we provide a multi-source 3D data integration, which you can see in the figure, or the oblique data, the BIM, or building information modeling. And then we have the point cloud to be open in SuperMap, symbolize the 3D modeling. This can be used for pipelines, and then 3D field data, manual models, and 3D terrain. And not only storing, processing, and analysis, but for the visualization of the 3D data, we provide 3D interaction and output technology using WebGL, VR, AR, and also the 3D printing. Okay, this is the summary we support for the 2D and 3D integration data model, 2D and 3D integration GIS, multi-source 3D data integration, and also the 3D interaction and output. And this is more detail on what data can be supported by SuperMap for the 3D data, the oblique photogrammetry, point cloud. So we can create such a cache file of your point cloud and then bring them to the cloud-based application system. And we also support to analyze the underground pipeline, open the manual modeling for your simulation, simulate 3D scene, and others. Okay, so this slide shows you about the example of three-dimensional modeling with its complexity and details. So not only in desktop application, SuperMap can bring your data, analysis, and visualization in another client, such as a web-based or even mobile phone. And this case is for web-based application. So this platform was created by using SuperMap as the engine. So we also bring not only for the data display, but also for the data analysis in the cloud-based application system. So yeah, the analysis itself then can be implemented to the data to gain new insight. So in SuperMap, all analysis that provided in desktop desktop application can be bring as well to the cloud-based application. So I will show you some of the analysis in this picture, in this video, in today's presentation. Okay, the fourth one is the distributed GIS. So this technology is used to support performance in overcoming the big data. Big data is a type of data that is large in number, updated quite often with many variations. So it requires special treatment so that it can be stored, analyzed, and visualized properly. By using the distributed GIS, distributed technology to be precise, we can divide the computational workload across multiple machines in order to keep the performance well. There are 5 concepts in distributed GIS in SuperMap. First one is we have the Edge GIS technology, Cloud Native GIS technology, Distributed Geospatial Analysis and Processing technology. So as you can see, that there is one word, distributed, so it's a bit different with the common Geospatial Analysis and Processing technology, because we can implement this kind of distributed technology, especially for the big data, and then the distributed geospatial data engine technology, and last one is the geoblockchain technology. So blockchain is a technology that is being discussed recently because of its ability to maintain data security. The blockchain SuperMap is already integrated with GIS, so that it can also be used to maintain the security of the GIS data. This is one of the example of the implementation from the geoblockchain for cadastral parcel management. In the cadastral management system, it is easy to implement the trace function of parcel changing based on the geoblockchain. The key data like parcel boundary, line, and boundary points can be managed by geoblockchain to avoid the malicious modification. And last, we have the cross-platform GIS. So from cross-platform, literally, or to put it simply, we can say that now GIS can be used anywhere, not only on PC, but also mobile, cloud, with a quite variety of operating systems, such as Windows and Linux as well. And SuperMap support not only in Windows operating system, but we also can be implemented in the Linux operating system. And we have various terminal from the desktop, PC, desktop is PC, and then cloud-based application and also mobile application. Okay, sorry. Okay, next is the product technology of SuperMap. Okay, this is just a information for you that this is the product family of SuperMap. We have many kind of terminal products that are Cloud Edge, mobile, WebGIS, and also PC. We have the iPortal. iPortal is SuperMap GIS portal, and then we have iServer. iServer is GIS server, and also iManager. So should you already have so many server in your project, and iManager is can be used to automatically deploy the server setting, so you don't need to do it manually one by one. And then we have also IH. IH is to leverage the performance of your server. It kind of do the replication of the functionality of your server. And we have also the iMobile. In the iMobile, we have 2 different products. The first one is iMobile, and the second one is iTablet. What makes it different is that iTablet is ready to use application, but iMobile is you need to do the further development to get your application, because we provide it as software development kit or SDK. And we have also iClients, so it provides so many API, both in JavaScript API, 3D WebGL, and others to support your WebGIS development. And last, we have the PC, iDesktop.net and iDesktopX. And today we are going to use the iDesktop.net instead of X. So for AI capability, it can be used only in iDesktopX. We cannot use that in iDesktop.net because it needs Python environment, and Python is only can be supported in the iDesktopX. And also IRIS.net can be used only in Windows operating system, but IRIS.X it can be used in both Windows and also Linux operating system. And last, we have iObject. iObject is for the customization developments based on our desktop products. Okay, just for your information is that SuperMap is actively in collaboration with university. So this is one of some pictures from the real training that organized by SuperMap. This is a live training, so we are coming to the Egypt, Turkey, and others to do the on-site training before the pandemic situation. So the training itself, the purpose of the training is to introduce the SuperMap technology to them so they can gain new insight from new technology. But because of the pandemic, used to change the training method to be online, such as in Iraq, we already have organized our training by online, and also today our training for Nepal University. Okay, and for today, main presentation is we will discuss our spatial analysis capability in SuperMap. With me, Gandes from Indonesia as a SuperMap technical engineer that's responsible for Asia and Oceania department of SuperMap International. Okay, before I show you the live demonstration, I want to let you know that our desktop product, it has so many rich analysis and GIS function. So for the basic GIS functions such as the database management, query, and others, of course, we support mapping. But in SuperMap iDesktop, the 2D and 3D capabilities is combined into one software. So there is no iDesktop for 2D only, iDesktop for 3D only, but we can analyze both 2D and 3D in iDesktop.net or iDesktop.x. Okay, this is only a few of them. I don't put them all because it will give very little font. But today I just show you some of analysis that can be solved by using SuperMap. And should you have any question about my presentation and live demonstration after this, you just can put your question in the Q&A chat box, and I will answer it in the last session. Okay, I think we now go to the live demonstration of SuperMap Spatial Analysis. And this is the software we are going to use, the SuperMap iDesktop, the latest version, 10.1.1, that you can download in our website in supermap.com. And it will be automatically 90 days trial in the beginning. But should you want to extend it for education purposes, you can just let me know or Jarin. We will help you to extend the trial license. Okay. Sorry. The first analysis, first demonstration I want to show you is about the registration and 3D rapid modeling. So before we analyze the data, we need to make sure that the data itself is already has a coordinate system or other geographic information so that you can do the further spatial analysis. Now I have two different data here. The right picture is the map that already being scanned. So we have the digital version of that. And also the left one is I have the reference point, 4 reference point that representing each edge of the map. So the reference point, it already has coordinate system in the form of vector file. It comes from the real measurements, and the right picture is the map picture. So it is a raster file in the form of GPG file, has no coordinate system and no geographic information. And today we are going to register this map based on our reference points. And this is the flow for the registration. Now, the first one is we need to create a new registration, select the reference dataset, select the registration algorithm, and then pick the control points, calculate the error, and finally we can execute the registration. Okay, I think now I will share my my iDesktop. Okay, this one. Okay. So this is the visualization of the iDesktop, our desktop product that can be run in Windows operating system. So as you can see here that we have the ribbon menu here, right? And this one is content sensitive because of should we open our 2D data, the 2D operation will turning on. And if we open our 3D data, the 3D operation will turning on. So now there is no 2D and 3D object operation because of we don't open any data. But now we are going to create a new data source. So data source is our spatial database format. So you need to create a data source first before you import any data. You can just right click in the data source and new file data source. You can type the file name such as process. And now we import our data. To do so, you can right click and import the data set. You can click on add file here and select your data. Data that we are going to use, the first one is the New Haven in the form of GPG file, and also the shape file point of our reference points. You can click open. Okay. Special case for raster file. So in SuperMap, you can import your raster file as an image or as a raster. What makes it different is that if you want to analyze your raster file for further analysis, such as for further analysis, such as you're going to analyze the digital number of the raster file, you can choose raster instead, such as for the satellite imagery, you can import as a raster. But for this case, since we are not going to analyze any digital number of the raster file, so we can choose image instead. And there is no other further setting for shapefile. Just can click import and wait until it finish. Okay, once it finished, it will appear under the process data source. We have the New Haven. We can open it in a new map, right click and add to new map. And it will look like this. This is our New Haven data. It has no coordinate system. How to check? You can right click and go to the properties. And in here, it say that the coordinate name is planar coordinate system and there is no projection parameter. But in the reference points, it has coordinate name and also other coordinate parameters. So we will refer to the reference points to do the registration for our map data. Okay, this is how the reference point look like. You can add to new map. So it has 4 points that representing the edge of this map. Okay, we can close this because we will not use it again. And now go to the start. We have the registration here. And click on your registration. The first one, you'll be asked to select the data that's going to be registered, not the reference points, but the New Haven instead. Next, we are going to choose the reference data. It should be the reference points. This one, okay, finish. And it will give you 2 different map window. The left one is for the registration layer, and the second map window in the right side for the reference layer. So now time to digitize. As I said before, that these 4 main points is representing the edge of the map. So this edge should be for these points. And now we go to another side of the map. It should be here. This one is this point. And the third one, this point is for this point. And last, we have our last point. This one, it should be this one. And you can right click to end. But we cannot register it immediately because we need to calculate the error. You can click on the calculate error here. And in the table under your map window, you can know the RMSE. So the RMSE is representing the error of your registration. So this error it will be good if you have less than 1 pixel. So the unit for this error is 1 pixel. But for this case, I got 2.8. It's not really good, but so you can just repeat it again, such as if you want to delete one of the points, you can right click and delete, and then you can pick the point again. Oh, maybe I will show you how to do that. You can right click, delete, and click pick again, digitize the control points, this one, and calculate the error again. Apparently it's getting worse, but yeah, you can just try again and try again to get a better result. Okay, just for the demonstration, I will just let it default as 3 pixel for the error and go to the registration. Okay, in the registration, you will be asked to define the result data source and also the name of the result dataset. So here I will save the result under the process data source with the name New Haven 19 and 84 adjust. And you can also select the resample method. We provide bilinear, nearest, and also cubicle. For this time, I will use the bilinear instead and click OK. And wait until the process finish. Okay, while waiting the resampling, I think I can show you the next process we are going to have. Okay, is after we successfully register our data, next part is I will show you how to do the rapid modeling in SuperMap. So in SuperMap, we can make a very simple 3D model based on vector data. So first, we need to create a new vector data set and then define the coordinate system, digitize, define the height, because we are going to extrude the model based on the height we have put in our data, and open it in the spherical scene, set the style, and also give some texture to make it more beautiful. So to do so, I think I need to go back to the desktop. Okay, repeat. Okay, I think now it's done. We can open the result into a new map. There is a prompt message. You want to build image pyramids for the data. To speed up the display, you just can click yes. It will not change the data itself, just for the display purpose. Okay, I think now it's done. Okay, it works. Now we have our map that already adjusted, registered based on our reference points. Okay, if we check the properties, now it has coordinate name and also the other coordinate properties. Okay, now it's good. Okay, before we create the 3D model, we need to create a vector data. You can right click and add new data set and change the type into region, change the data set into building, data set name into building, I guess, and click create, but it will have no coordinate system, but we can copy it just from other data, such as from reference points or the New Haven adjust result. Click OK, and now it has coordinate system. So no need to do an registration, but you can just copy the coordinate system because this data set has no records data, right? It's still empty. So you just need to define the coordinate system. And now we can just drag it to the map window. So it will appear in the layer manager, the active layer. And to do the digitization, you can double click the pen editing tools, this one in the gray color, double click on that. And the object operation menu will be turning on. So you can click region to do the digitization for region. And now we can start to digitize our object. And you can right click when you finish. Maybe this one. And you can right click when you finish. And we provide another process to achieve the digitization by using the raster to vector, and it will raise the time of your digitization to make it faster by using the vectorized region. But actually the concept is to do the raster to vector conversion. You can click setting first. I will need to define the color tolerance. So what is color tolerance? So yeah, it represents how resemblance are the colors. It will continue to track when the weight of the RGB is less than tolerance. So it's kind of the threshold to allow the software to whether to continue to track as an object or not. Okay, I think I need to go back to the iris stop. Okay, this one, and we can define as 50. But the number of the color tolerance is depends on the imagery. For this case, we will try to use 50 instead and click OK. Click on the vectorized region and you can click on the object you want to digitize. Just one click, it will detect automatically the object. Yes. Okay, and you can right click when you finish. The result is maybe not as good as the one that we manually digitize, but at least it can save your time by using the vectorized region. Okay. Next part is we need to define the height of the building. You can right click of the building dataset, browse attribute table. So now we have 19 building here, but it has no height information. There is no height information, so we need to add new attribute, add new field. You can right click and select the properties, go to the attribute table and click plus to add new field. I think I can change it into height and change the type into double and click apply. So it will be appeared as well as this. And now we can define the height. To define the height, you just can put any number. For this case, I think I will put 200, 300, 400, 500 and just copy it to another data. Okay, now we have defined the height. Close the attribute tab and go back to the map window. To open our data in 3D scene, we need to select our data again. You can select the building and also the adjusted New Haven map and right click and add to spherical scene. So you will get an earth globe like this. You can right click on one of the data here and zoom to layer. Okay. So this is our result. It opened in a 3D. Because of the teleconference limitation, I think it will not run smoothly in your screen. But actually, if you can try it by your own, it can be run smoothly, our 3D. Okay, now so you can click on your building layer, go to the style setting. Okay, we are going to extend our building, we change the altitude mode into, you can select either absolute or relative to ground. I think I can use absolute instead. And the height is the height field. So it will look like this. This, okay. So we extend our building based on the height field that we have defined for. To make it more beautiful, we can add some texture. You can click on the texture setting here and the 3D texture manager will appear in the right side. And you can select the texture file. So we support the PNG, GPG, even GIF data to be act as the texture for your building. And I have already prepared. I will use this site file and change the tiling U and tiling V, such as this one. I think one by one is pretty good. This one, and also change the top texture. You can select file in top texture, select the top file. So it will look like this. All right. So I think this is the final result for our first session. You can right click, save scene, put the name, and it will be automatically saved under the scene. And you can close, save the map as well, save map. It will save under the maps. You can close, and you can also close this. No need to save. And now we can save the workspace. So should in another occasion you are going to open your scene and map, you can just open your workspace. Save workspace. Or maybe this one. Okay, and you can also put some a password here. Should the data is so secure, and then click save. Okay, we can close it now and go to the next analysis. Okay, after we successfully do the registration and 3D rapid modeling, now we go to the modeling and analysis. So in the modeling and analysis, we will do some spatial analysis. So we have a building data and road data, and we are going to query one of the route by using SQL query. And from this selected route, we will do a buffer analysis. This, and from this buffer result, we are going to look which building are affected by our road extension. So we will use the overlay analysis of buffer result and building to know the affected building of the road extension and show the result not only in 2D map but also in 3D scene. And these two display is linked to each other. Okay, now go back to the desktop. Okay, I think I have closed all of the previous data. Now I will open my existing data source. So for this time, I will not show you how to import it manually because I have shown you before in the first tutorial. So I just open my existing data source. You can right click and open file data source. And now we need to select our data. This one. Okay. I have one data source in the form of UDB, modeling and analysis. Okay, I have two data here, road line and model region. You can select them all, right click and open to a new map. And it will look like this. And we are going to query one of the road that to be extended. So you can go to spatial analysis and select the SQL query. So there are two different query we can achieve in SuperMap. The first one is the SQL query and second one is the spatial query. So in the SQL query, you need to put the expression of the query, and in the spatial, we can analyze the we can do the query and the spatial analysis in the same time. So first we will go to the SQL query first. In the SQL query, okay, we can clear the existing expression, and please make sure if you select the root line. So you need to select the root line, and in the select, we will select all and put the expression here where the root name is equal to, you can click on the get unique value is equal to the single root, this one. And you can show the result in the browse attribute tab, highlight in map or highlight in scene. And for this case, I will uncheck the browse attribute tab and select the highlight in map and highlight in scene, and also save the results of the query results and click query. Okay. So now we have two different map windows here. The left one is for the 2D and the right one is for the 3D, and it linked to each other. So if you move the map, the 3D scene will move automatically. And yeah, this one in the blue color, the highlighted one, is the result of our query. Or we can also import our query result to the map window and the 3D scene. And you can also put the model region file to the 3D scene like this. And now I think to make it better, I can change the height of the building in the 3D scene. You can go to the style setting, but you need to make sure that you click the query result first, and then click the model region. So first you need to click query result, click the model region, go to the style setting, altitude mode relative to absolute, I think, and the height is height building. So in the model region dataset, we already defined the height information. So you can just define it as the height to extend your building in the 3D scene, so that you can get this kind of visualization. And the next part is I will change the style of the query result. You can right click and layer style. So the style setting window will appear in the right side. So I'm going to change the width into 1 and change the color into red. So it will be appeared like this. And for the scene, I will change the query result style as well. You need to do it point by one, because for the style, it will not be linked automatically to each other. Change the style into red. Okay. So this is the result. And next is we need to do the buffer analysis. So to do so, you can go to spatial analysis. In the spatial analysis, we have so many capabilities, both for vector data, raster data, and you can find the raster analysis here. And for the 2D, for the vector analysis, you can find the vector analysis, facility network analysis, or even in the data, you can do some data processing, such as append the row of your two different attribute table from two different data, update the field, dataset attributes update. It can be used for looking for a statistic of your data based on spatial. And this one is for raster, or maybe do some conversion from point lines and regions, this one and others. But for this case, we will use the very simple one, the buffer analysis. You can select the buffer zone, and in the buffer zone, we will do the buffer analysis for our line data, which is the query result. So we need to change the data type into line, and the data is plot line. Buffer type is we can select either round and flat. For this case, it doesn't matters. And for the buffer radius, we will set it into 20 meters. And you can also define the buffer based on the something that defined already in the attribute table as the field in this field setting. But for this case, we will define it manually. For the left radius and right radius, both is 20 meters. And you can select you can change the dataset name, the result dataset, and also the data source. But I will make it default and click OK. And now I get the result. So in the map, it will automatically import it. I think I can change it to be here on this one. And better to change the color probably to be yellow. Okay, like this one. And in the 3D scene, we need to import it manually. So you can just take the buffer result. This one, change the buffer position into as the bottom one, and change the color. Again, you can right click and go to the layer setting to change the color, maybe into yellow as well. Click OK. Okay, now we have the buffer result. And as you can see here that this road extension is affect some building, right? So we are going to looking for the affected building based on spatial relation. So as I said before, we will use the spatial query. You can go to spatial analysis and click on the spatial query, click the 2D spatial query. But before we do this analysis, we need to select data to be processed. You can change your cursor into select, change your mouse, and then select the buffer result. And after you select the buffer result, you can go to spatial analysis, spatial query, and 2D spatial query. And here we will process the buffer analysis and the building dataset. So we have selected the buffer result, and now we will select the model region, which is the building, which with the condition is intersect. So we are going to highlight the intersected building from the model region with our buffer result. So you can click intersect region and save the result and show the result, highlight in map and highlight in scene. No need to browse in attribute tab for this case. And click query. And it will show you like this. So the highlighted part will be, so the building that affected by the route extension will be highlighted in the blue color for the map window, and for the 3D scene, it will be highlighted in blue color as well, but it's quite similar with the green one, but this one is the one that is affected by the road extension. Okay. All right. I think this is the final result for our analysis. And of course, you can achieve more by doing some integration from the spatial analysis that provided by SuperMap, probably for the network analysis or even for the pipeline analysis in the 3D. So you have to get your own 3D pipeline to be represented by using our 3D symbol, and you can further analyze them using our capability in facility network analysis. It can be run for pipeline or probably for other raster analysis, surface analysis, such as to extract the isoline, vector converter from raster to vector, or others, the statistic, the distance raster, interpolation, hydrology, and others. And we also provide some special statistical analysis that can be used for your requirements. We have the measuring geographic distributions, analyzing mode, and others here. Okay, I think I need to save it first. You can right click on your scene. Oh, for this case, we cannot save that because of, oh no, oh yeah, you can just click yes. Okay, and also for this map, you can right click and save map, and it will be saved under the maps, and the scene will be saved under the scenes, and you can close. And now we can save the workspace. Save workspace, select your directory file, modeling and analysis, spatial analysis. Click save. So click save. After you save, whenever you want to open your scene and your map, it will be the same as you have created before. I think I can show you. So let's say I have closed our workspace before, and now I will open it again. You can right click and open file workspace and select your workspace, so you can open your map again like this, and this is for the scene. Okay. Okay, I will close it. Now we go to the last tutorial. So after we achieve the 2D spatial analysis, last I will show you the 3D spatial analysis in SuperMap. Okay, so in SuperMap, we have our capability to very well in analyze, prepare your 3D data, either for only for desktop purpose or sometimes also for the cloud-based application system. Because if you develop a WebGIS by using SuperMap products, which is the server, our server or our portal, you need to do the preparation of the data first in our desktop product. So you need to create a cache to leverage the performance in displaying the 3D data in a cloud-based application system. But for today, I will just show you how to achieve some spatial analysis for 3D data in SuperMap iDesktop. Okay, first one, we are going to analyze data that have elevation information. Maybe you're already familiar with digital elevation model or DEM. We are going to analyze the DEM data. First, we going to analyze the isoline analysis. So isoline analysis in SuperMap will show you the isoline result by overlaying it on the DEM data in 3D way. Okay, I will go back to the iDesktop and show you how to do so. To do so, you can right click in the data source. So I have imported my DEM data before, my digital elevation model data, open file data source. This one. And I have three DEM data here. So because for this opportunity, we are going to analyze the digital number of our raster data. So we need to import them as a raster. So like before, since we are not going to analyze our map, the New Haven, that's why we import it as the image. But for this case, we import the raster file as the raster. And data we're going to use is the DEM25. Let me show you how it looks like in a 2D map. So it looks like this. And now let's open it to the 3D scene. You can right click and add to just spherical scene. Okay, you need to import as a terrain and image at the same time, and it will be located here. Okay. Now we will analyze the data. So since I have imported 3D data, the 3D operation will be turning on. So you can see here we have the scenes, 3D analysis, and others. So SuperMap provides so many spatial 3D analysis for 3D data, such as the slope and aspect analysis, isoline analysis, flooding analysis, and others. And we are going to analyze the isoline analysis first. For the isoline analysis, this isoline, flooding, and slope it can be run only for data that have elevation information. So some model probably don't have any height information, so that we cannot achieve any analysis that require the height information, such as the elevation information, such as the flooding, ice line, and slope. But for this case, in our digital elevation model, it has elevation information, so that we can do the isoline analysis. So after you click the isoline analysis, the 3D spatial analysis will appear in the right side. So you can click on the isoline analysis and click the plus button here to add a new area. So you'll be asked to draw a polygon to proceed the isoline analysis. So you just need to draw it. And right click when you finish. So the isoline result will be appeared like this, overlay with your DEM data. And you can do some further setting here in the parameter settings, either to display the mode of blend mode, contour only, texture filling, or both of them. Choose the line color, the texture color, transparency, the minimum visible altitude, the maximum one, the interval of the contour. Maybe I can change it into 60 to make it, to just show you how the difference. And other setting can be done in the parameter setting here. And next, we go to another analysis, the slope and aspect analysis. So slope is the gradient or steepness of a unit of terrain, while aspect identifies the downslope direction of the maximum rate of change in value from each cell to its neighbor. So the main difference is that aspect, it shows the direction. So we are going to get this kind of display, this kind of result in iDesktop by using our own data. We can go back to iDesktop, and we have the slope and aspect analysis here. But before that, I think I need to delete my previous result first. So you can select your result and click delete. And now I will choose the slope and aspect analysis. And you can right click when you finish. So this is the result. For this, the first time is I will just only show you the slope display, but then I will change into aspect display, this, and both slope and aspect. And you can also change the transparency, the color table, and if you click on the flow, it will give you this kind of simulation to show the direction of the aspect. Okay, now we go to the next part, the flood analysis. So it used to simulate the flooding process over a duration of time with the specified speed and within the maximum or minimum elevations. So flooding analysis in SuperMap only based on elevations. So you cannot involve any other parameters to achieve this kind of simulation, because it's only based on elevation of your data, but doesn't rule out of the possibility if you want to do the analysis by using integrating by integrating some others parameters. You can do it by yourself, but you cannot use this function flood analysis in SuperMap because of this only for elevation parameters. Okay, I will go back to the iDesktop and show you how to do so. We can delete our previous result, the slope, can delete, and now we click on the flooding analysis. Just like before, we need to draw our area. You can right click when you finish. Oh, I think it doesn't successfully store. I will repeat again. You can right click and define any other setting here. Okay, as you can see here, the water is start from the bottom one to the top elevation in our area. And you can set any other parameters here, such as the texture, color, the transparency, the minimum visible altitude, the maximum visible altitude, the total time of the simulation, or even the speed of the water move, you can define it here. And if you click loop, it will always show you the simulation. All right, this one is for flood simulation. Now we can close our scene. No need to save for this time. And I will go back to the presentation to show you another analysis we can achieve in SuperMap. So after flood analysis, we have the feasibility analysis. So it's often used in 3D analysis. This function is used to determine whether certain location in a 3D scene are feasible to the observer location. Okay. I think I will go to iDesktop again, and we will use another data for this case. We can open another data source, the CBD one, this one. So I have some model here. You can select them all and right click and add this new spherical scene. And then right click here and zoom to layer. You can select just one of the layer, active layer. Okay, the data successfully imported. So we have our center business district 3D model here. So this model is not created, it's not created in SuperMap, but it had been created in other software, but then we import the data. As I know, the data is created in 3D Max. So we support to open the 3D Max data, 3DX Max data. Okay, now you can go to the 3D analysis, and we have some 3D analysis function here. Let's start with the feasibility analysis. I will use this model. You can click feasibility analysis, and first you will be asked to draw the viewpoints. I think I will set it here, and now draw the point being observed. This one. You just can draw as many as you can. And you can right click when you finish. So the green line means that this point can be seen from this point, while the red one, it means that this point, it cannot be seen from this point observed, from this observer point. So yeah, the difference is on the different color, representing whether the point it can be seen or cannot be seen. Okay, now we go back again to the PowerPoint. Next, I will show you the fused analysis. So actually the main idea is just the same with the feasibility analysis, but the fused analysis will give you the result in the form of area instead of line. But the result is also just the same. The green area means that it can be seen from the point of view, and the red area is cannot be seen from the point of view. Okay, let me show you. We have fused analysis here. Okay, let's find another area. Probably here. Okay, you can click on the fused analysis and draw the start and also the endpoint. You can right click when you finish. So from if you stand here, let's say one person stand here, and from this person point of view that located here, he or she can see the green part but cannot see the red part. So you can also define the viewer info here, such as the height of the person that stand here, because the height will affect the result, right? So you can define it here, and then this one, the vertical perspective, the visible area, color, the quality, and others. And to make it better, you can also do the simulation. Let's delete this one. By using the dynamic views, so you can draw the line to proceed, the start and the end. You can right click when you finish. So it will give you a simulation. For this case, since I choose male as the role, so it will looks like a male walking from your start point to your endpoint, and also the result of the fused analysis will be appeared as well as together with the man walking. Let me show you in a proper way. This one is for the dynamic fused. And if you want to draw more than one fused analysis, you can use the multiple fused analysis. Okay. Next is the sunlight analysis. So this analysis is used to calculate the duration of sunlight in a period of time within an extent defined by longitude and latitude. Okay, to do so, it's very easy as well. We can delete our fused result, I think. And also this one. For the fused analysis, feasibility analysis, we can delete them all. And now we will select the shadow analysis. So we have to draw a polygon again, probably here. You can right click when you finish, and the result will be appeared once you click the area. All right. So it will automatically create a grid and show you the different color that representing the different daylight rate. So it based on the time that's set here, and then the software will automatically calculate the daylighting rate. Such as this one has 85% of daylighting rate, while this one is only have 23%. So you can define it here. And also define the maximum height, the sampling distance. So for this time is 5 meters to each other. Okay, so different color representing the different value of the daylighting rate. Okay. And last, we have the skyline analysis. So this function will allow you to generate the boundary between the building tops and the sky from the observer points. Okay, it's very easy. You can go back to the iris top. I think I haven't shared. So this one is for the skyline analysis to generate the boundary between the building tops and the sky from the observer points. Okay. To achieve this skyline, we need to set our point of view. Okay, and now click on the skyline analysis and change the skyline color into red. Okay, I think we can turn off our building, and this is the skyline result. So it will generate the boundary between the building and also the sky. Okay. Oh, it should be the last one. But actually in SuperMap, we have another 3D analysis such as the open analysis, the profile analysis, and others. You can try it by yourself. And I really encourage you to also try to open another data, especially for your own data. Should you want to import any BIM data, the process is a bit different for you. If you import any other data, you just right click on your data source and choose the import dataset, but for BIM data, you can right click and import BIM data. We support to open the 3D XML, Revit, IFC, and also CTGML. And you can analyze further in our software. And even if you want to open your 3D data by using our AR augmented reality application, the preparation process is also done in our desktop product. You can try by yourself. Okay, and last, I will share the data for you. You can download the material here in the bit.ly/smc web material, or simply just scan the barcode QR code I put in this presentation. And also this video is recorded. Our session today is recorded and will be uploaded in our YouTube. So you can have a look in our YouTube again to know the entire process that I have delivered today. So you can follow the tutorial to achieve your own processing by using our data that already shared here. And should you have any question while attempting the process, you can ask me by using email at gandis@supermap.com. Okay, I think that's all for today. Thank you so much for your attention, and the session I will give it back to Jarin.
Thank you, Gandhis, for the wonderful demonstration, and I'm really hopeful that we will be able to get the most out of this demonstration. So everyone, I'll be moving forward to the Q&A session. So I already am seeing several questions in the Q&A box. So I'd like to request Gandhis to take a look at this.
Okay, so I can answer it right now, Jarin.
Yeah.
Okay, first question is from Jason Poheral. I'm very much interested in artificial intelligence. Does SuperMap provide both classification and regression solving algorithm? So for artificial intelligence, we provide the ready-to-use toolbox under the machine learning toolbox in SuperMap iDesktop X. So you can use that for the classification. Especially, we have two different classification here. We have the object detection, and the second one is feature extraction. I think classification is more on the feature extraction, because the main goals for the object detection is just calculate the number of the object based on the shape and also the location. But feature extraction is you can obtain the shape of the real feature by using our feature extraction features. Second one, can you please send the link download? Oh yeah, I will share you the link to download the product in the last session today. And then, are there file formats of the data default to SuperMap? And how interoperable? Okay, for GIS data, the common GIS data, it can be open in SuperMap. I think I can show you how to check. Jarin, may I?
Yeah, sure.
So you can check it here. Import dataset. So if you add file and take a look here. So here are data that supported to be open in SuperMap. We support the common GIS files such as the TIFF data, the shapefile, the ECW, KML, and others. It can be open in SuperMap, of course. And also we have our capability to open the 3D data for the LiDAR data, TIN, and others. And for BIM data, as I said before, for building information modeling data, it is a special case because you don't need to use this flow step to open the BIM data. You just need to right click and import BIM data. We support the IFC, 3D XML, and then Revit data as well to be open in SuperMap. Okay, next. How we can, for Sharif Sharma, how we can use SuperMap on cadastre era. Just for your information is that SuperMap have our we have our cadastral 3D cadastral plugin, but so it was like if you have your drawing plan data, and you are going to digitize them and make it as a 3D. We support it by using our 3D cadastral plugin. So this 3D cadastral plugin is not available yet in our website, but if you want to try, you can let me know so I can give you the trial license of the 3D cadastral. And the main goals of this plugin is that after you import your drawing plan, then you need to follow the sequence step so that in the end you can obtain your own 3D model from your drawing plan. So the data that need to be processed is only drawing plan and also the such as a database information. And from these two data, we can obtain the 3D model from your cadastral. So it was like you make a 3D model, but you also can to put some legal information or another information into your attribute of your 3D model data. And of course, for the basic ones, such as to manage your cadastral data, cadastral shapefile data, probably it can be done also in SuperMap, probably to check the topology, to check the relation with another spatial data. You can do that in our software. Visual Cut3, in which software is this 3D model created? We are using the iResTop.net. So you can, I can show you how to download our product. Okay, so you can go to the SuperMap website and in support download. Okay, today we use the iResTop.net. This one, you can download either the 32 or the 64-bit based on your laptop requirements. And we have two different installer here. The first one is binary and the second one is the default. So the default one is, the size of the default one is bigger rather than the binary, because this binary is deploy version. So you don't need to do any installation, just unzip the file and then you can run the software. So whenever you want to open the software in another laptop, you can just copy the installment folder to the another laptop. But it has no, as I know, it has no sample data and also has no help documents for the binary. That's why the size is less. But for the default one, you need to install it first. And it has the sample data and help document as well. Okay, this one is okay. Yeah, this is for the installer. You can download the .NET version of our iDesktop product, 64 or 32 based on your computer requirements. Okay, we move to another question. What is the minimum specification required to install the app? Okay, let me show you. This is the minimum requirements to install software. I've shared the PDF, right? Okay. This is the minimum hardware requirements. This one is for the recommend. And for 3D, we have other requirements. You need to at least have 2 gigahertz core processor and 512 megabyte RAM, and also the free disk space. And for the operating system, we only support for the Microsoft Windows. Okay, I think you can just screen cap the screen to get to know the requirements. Okay, this one is for the requirements. Next, can you show us the layout view and some tools used for map making or the layouting? Okay, sure. I will close it. Okay, I will share my desktop again. All right. So to do the layouting for our map, first we need to have the map. So we can open one of our data here to the map window and then save the map. Save the map as it appears under the maps here. Then we need to create a new layout. So you can right click in the layout, click new layout. We select the blank template. And now you can go to the object operations, click the map, and you can select the shape of the map, either rectangle, polygon, circle, or others. You can select the rectangle one, and you can draw an area and select the map. And for this case, since we only have one map, you can just select the map and click OK. And this one, okay, now we have the map. And if you want to change the position, you need to go to the layout, focus map. So if you click focus map, should you scroll your mouse, it will make zoom in and zoom out your map only, but not for the whole map window. But if you unclick the focus map, you will not be able to set your map. So you need to focus map first, such as this one. Okay. I think better to make it horizontal, right? Okay. Next. All right. Next, maybe you want to add grid, for example. You can click properties. Okay, you need to click on your map, right click and select the properties. Go to the layout map properties, and here we have the map grid. You can add one map grid. You can select either the critical or the measure grid. For this case, I will use this one. So I will, I think it's too many, right? Okay, I will delete it and create it again. This one is enough. And next, maybe you want to add some titles. Titles in the object operation. You can add text. Maybe the name is raster map. And add some map information, such as you need to select the map first so that you can activate the legend, north arrow, and other things here. We want to draw the north arrow. And then add the scale. Or probably the legend. Oh, just one legend because we only have one data here. Nothing, no need to put any legend. And others. You can explore it by yourself. So after you obtain, after you finish your map making, you can save the layout and it will appear here. And also you can export the map. export and print, you can export to picture, export to PDF. You can do it here. This one is for the map layouting in SuperMap. So the main process is that you need to have your own map. After you have been through the long process to obtain the map, and then you need to save the map. And after you have the map, you need to create a new layout and import your map and add some map things such as the legend, the north arrow, the title, the grid, and others. From one Nur Shahira, when I try to click the download, but it doesn't appear in my download folder in Google Chrome. Is there any other way to download the software? Oh, this also common happen to others. I think you can use the incognito instead. So I'll suggest this one. So in the Google, you can select the new incognito window. So it will be appear here like this, the incognito window, and you can go back to the SuperMap website and copy the link, such as I'm going to download this one, the SuperMap iDesktop Windows 64, the full version. You can right click, copy link address, go to the incognito window and paste it, enter, and it will be automatically downloaded here. Okay, I hope it can help you. So try to use incognito windows instead. Okay. Yeah, you're welcome. Okay, now another question about the license policy. I think you can ask Jarin about this since she is responsible for Nepal. I'm not sure because I'm the technical person here. You can further have a discussion with Jarin about the license information. Is Everest Spirit 19 and 30 projection system available? Okay, let us check. Say for this data, this coordinate. Everest 19 and 30. I think we have 18 and 30 here. Yeah, we don't have for the 19 and 30, but we have the 18 and 30. Or maybe you can let me know the EPSG code and I will confirm it to you later. Okay, for Pinot Bata. It's available. How can we convert it to WGS 19 and 84? Yes, of course. We can do the conversion to the WGS in 1984. So in SuperMap, we have two different ways to transform. First one is the reset coordinate system, and we can do also projection transformation. So if you do the reset coordinate, so the original file will not be saved. But if you choose the projection transformation, it will create a new file with new coordinate system. So I think better for you to use the projection transformation instead, because you can still be able to save the original data before you transform it. So such as I have one data here. I will create a new data set, point, with name transform. It has no coordinate system, but I will define the coordinate system into let's say Beijing 54 Albers equal area. And now I will try to transform my data into WGS 1984. And you can also click more to check further information of the coordinate system that provided in SuperMap. Okay, click. Okay, as I said before, if you choose the transformation, not transformation, if you choose the projection transformation, you will be asked to create a new file. But if you don't use this, but you use the reset transformation, it will override the original data to be transformed into a new coordinate system. So your original file will be lost. Okay, I will choose the WGS 1984 convert, and now I have the WGS 1984 for my transform data. This one is still in the Beijing coordinate system, Beijing 54 coordinate system, and this one is already in the WGS 1984. Oh, yeah, we have the average 18 and 30 as I showed before. Okay, I think that one is the last question.
Yeah. Yes, that was the last question. Thank you, Gandhis, for your time. And if you guys have any more questions, please feel free to send email to Gandhis or me at jayunsupermap@gmail.com or jayun@supermap.com. We will be trying to give you answers soon. So now I would like to welcome Dr. Rishma Sreshta, Assistant Professor of Department of Geomatics Engineering, Kathmandu University, to give us her valuable remarks regarding the geospatial science and SuperMap. Ma'am, can you hear us?
Yes, I can hear you. Can you hear me?
Yes, we can hear you. The
Audible?
Yeah.
Okay. So first of all, good morning to all the participants and also the SuperMap team, Gandhis and Jarin, for the wonderful presentation. And also, I would like to thank you, this GS Society, for having these initiatives to let this event happen. And also like SuperMap team for having such an in-depth tutorial series, basically in the spatial analysis. And basically, personally, I'm very impressive with the presentation on the daylight analysis and skyline analysis, which I feel very important in the urban planning domain. So now, having understood the history of SuperMap, which is serving in a geospatial community for such a long time. I guess it is founded in 1997 in Beijing. And also its wide range of products, very spectrum of products from this big data, integrating GIS with AI and 3D modeling and this solver with GIS. Now it can be a questions like how this SuperMap product can be integrate with the university for the education purposes and also for the research beyond the we are talking beyond the already know before as well that our department is basically focused on the application of this geospatial technology in the various sectors like from land management, agriculture, forestry, and even like urban dynamism. Now, we are also very keen interest to, I think, to have some collaboration with SuperMap products, like how we can get subsidized or free license, just that we can apply that use for our daily integrate in our curriculum of our program, geomatics program. I think that can be very interesting to have some collaboration for the discussion in this matter. Now, also, I would say the another part is hopefully, as all of us know that geospatial community is slowly moving or lobbying towards free and open source software for geospatial. This first 4G is now coming up because it is the thing like it is always very difficult to have licensed software and also to become upgrade always, sometimes it becomes problem for the non-profit organization like the university and the department. So in that aspect is a kind of win-win collaborative model can be developed with the SuperMap from our side. And I think jointly we can have some product ready and some apply this geospatial technology to solve in this societal benefit. Like there are lots of societal issues we need to solve. And I think SuperMap can be one of the main point can serve, can help to solve this societal via geospatial technology. So this is what I would say. Finally, I would like to say that how SuperMap can collaborate with geomatics engineering department, having in providing this subsidized or free license software so that we can have further integrate in our curriculum in our department. That is very important. Finally, it is very wonderful presentations and everything. I think all the participants had got to know a very variety range of application of geospatial technology in various domains, even like urban, I can think this buffer analysis for the road extension in various, within this short period. I think all the participants has able to get a wider knowledge within this short period, and it is very wonderful presentations and this tutorial. Thank you, SuperMap, for this wonderful input to us, and thank you again for inviting me for the closing remarks from the department side. Thank you so much.
Thank you so much, ma'am. It has been a real pleasure to hear your valuable words. And as you were talking about the collaboration, and the main focus of SuperMap is the education and research. It's not really about the budget or something. We want to focus on the research-based activities. We want to contribute to the society, the geospatial societies. So we will be trying to contact you as soon as possible regarding the collaboration of Geometric Engineering Department of Kathmandu University. So we'll be looking forward to it. Thank you so much. So now with this presentation, I would like to add more to the speakers as Dr. Reshma Srishta was talking about collaboration. So I would like to invite you all, everyone here today to collaborate with us as well, because as I have said, SuperMap is focused on the education-based research, and it has been a prominent GIS software in the Asian countries like China, Indonesia, Bangladesh, Thailand, Japan, and also in most of the countries of Europe, North America, South America, and Africa as well. So we also would like to flourish and spread the technology in Nepal as well. So if you are interested regarding that collaboration scheme, so if you feel free to contact me through the given email, like zerinsupermap@gmail.com or jerin@supermap.com. We will contact you as soon as possible. Like here. So before finishing, I would like to announce about 19th SuperMap GIS contest, which has been arranged by SuperMap this year. So last year, more than 63 countries took part in that contest, and the participants from Bangladesh, China, and mostly Indonesia won the prizes for different categories. And so this year, we are expecting students from Nepal and adjacent regions as well. So here are the 3 categories for the students in the GIS contest, including the mapping group, the application analysis group, web and online development group. So this contest provides a chance for the students to improve the self-educated abilities, and the excellent students can also improve their abilities, and they can also get the job opportunities in SuperMap company during the contest. Students can not only use the advanced GIS software platform for free, but we can also send them the online technical support at any time, because our technical team works 24/7, unlike any other platform. And also top 10 students will be selected for the final competition, and the winners can win prizes up to $500 with certificates award. And they can also go to Beijing for free defense for the 19th International SuperMap GIS contest. And besides the teachers and the instructors of the universities who help organize the students to take part in the contest, maybe also get the certificates and the award. And So we hope every students here today will be registering and taking part in this competition. And so if you want to know more about the competition, please feel free to send us email at jwinsupermap@gmail.com or jwin@supermap.com. So just like I was saying that SuperMap always offers free training to the students and the GIS enthusiasts. So for the GIS contest 2021, we know that this is a very new platform to you guys. So SuperMap has arranged a three-schemed fees for free certificate-based online training, including the mapping training, the application analysis training, and the development category training. So excellent works and submissions from these trainings will be selected for the final competition, that is SuperMap GIS Contest 2021. So the extraordinary works will be given the challenge prizes as well. So as all many of the students know that two of the trainings already have finished till today. So if you could not attend the trainings, it's really okay. Just send us the email. We will send the materials, the data, and also the recorded versions of the training to you. And also you can start to join the Skype discussion groups and the Google Classroom. All the materials are there. And there is still one training left, that is the development group training, and which will be occurring at 1st June. So hurry up and join the online trainings, and you will be given the certificates and the chance to defend the SuperMap GIS contest for free. So we really do appreciate your attendance, and you are really more than welcome to access SuperMap website for free, and to get more information about the SuperMap. And we can also be found in the LinkedIn, Facebook, Twitter, Instagram, and you can also check out our videos in the YouTube. So thank you all for attending today's event. We will send the certificates to you within 7 working days. And SuperMap is providing 3 months trial license for the SuperMap software to those who attend today. So you can also email us for the packages. SuperMap will hold more webinars and SMCs in the future. So we hope that you will be able to meet you soon in the next webinars and SMCs. So till then, stay safe and stay healthy. And thank you for your patience today. And thank you for attending today. Have a great day, everyone.